Okay, so now that I have introduced um, the some of the terminology of quadratic functions, like um, the different types of the different forms that a quadratic function can be written in, and the expression versus equation versus function and so forth. Okay, let's now talk about basics of a graph, basics of the graph of a quadratic function. So any function can be plotted. You can figure out what the graph of any function looks like the long way, and that is just to plug in values for x. Well, hopefully, if we plug in 0 for x here, hopefully you'll see that we would get, think about it, it would get negative 12. So 0, negative 12 will be one of the points on this quadratic function. And this quadratic function, again, is written in standard form. Um, so what about if we plug in 1? Well, 1's pretty easy to calculate. 2 times 1 squared is 1. 2 times 1 is 1. 2 times 2, sorry, 2 times 1 is 2. Minus 2 times 1 again, make it 0, negative 12. So wow, it equals the same thing at 1 as it does at 0. So both of those points are going to be on this the graph of this parabola. Well, let's check out what the output is for 2. Now, I'm going to let the program do the arithmetic for me for 2. So I'm just going to type in f of 2. It's negative 8. So let's plot the point 2, negative 8. 2, negative 8. So that point will be on the parabola. Now, think about the symmetry of a parabola. If I have these 2 points are both on the parabola, and this point 2, negative 8, can you guess a point over here that would be symmetric to this point? Well, let's see what f of negative 1 is. Hey, look, when negative 1 is input, you get the same thing as when 2 is input. So, well, negative 1, negative 8. Are you seeing the symmetry? Obviously, the symmetry, we can see now. So we can see that this parabola is going to bottom out between 0 and 1. Between x equals 0 and x equals 1, it's going to bottom out. Okay, so let's see. We've got, let's see what f of 3 is. It's 0. F of 3 is 0. So that means that the point 3, 0 is on the graph, and that means that 3 is one of the x-intercepts. Can you guess what the other x-intercept is? Hopefully you're thinking it's negative 2. Let's confirm that. F of negative 2 is also 0. So that means that negative 2, 0 is also on this graph. So the graph looks like this. Boom. There's what the graph looks like. I wish I would. Okay, so now notice the symmetry of this graph. There's a line of symmetry for this graph. It's this vertical line right here. That vertical line right there. And the equation of that vertical line is x equals 1/2. So this line right here is called the axis of symmetry. The axis of symmetry. It's halfway between the two x-intercepts. It will always be halfway between the two x-intercepts. And it will always be halfway between 2 points that have the same output on the function. Now, this other point, the very bottom, well, that's the x-coordinate. We know the x-coordinate of that point is 1/2. Well, how do we find the y-coordinate? We find the y-coordinate by plugging in 1/2 into the function. So let's let the program do the work there. F of 1/2, it's negative 12.5. So I'm going to plot that point, 1/2, negative 12.5. Boom. So there's another point. So this point, as mentioned before, hopefully you realize this point is called the vertex of the parabola. And so we have x-intercepts, negative 2 and 3. We have a y-intercept, negative 12. We have a vertex, the point 0.5, negative 12.5. And we have this axis of symmetry that cuts the parabola in half, so to speak. So just here is a look at that vocabulary. So x-intercepts, every parabola, well, not every parabola will have x-intercepts. It could be all the way above the x-axis. But a parabola can have x-intercepts. It will always have a y-intercept. It will always have a vertex, and it will always have an axis of symmetry. So those are the important parts of the graph of a quadratic function. Those are the things you need to be focused on and be aware of and looking for when graphing quadratic functions.